In this tutorial, we're working with a KUKA KR 10R1102 robot inside iiQWorks.Sim. Our goal is to simulate a robot program that handles 4 different colored blocks and control it using WinMOD. Let's start with the logic inside your robot program. In the config.dat file, we've mapped digital inputs 120 to 135 to an integer signal called colorNum. This signal is used to determine which block the robot should pick. In the main routine, the robot waits for a rising edge on input 119. Once that signal is received, the program enters a switch case statement. Depending on the value of colorNum, the robot performs different actions. If colorNum is 10, the robot picks the blue block and sets output 103. If colorNum is 20, it picks the yellow block and sets output 104. If colorNum is 30, it picks the red block and sets output 105. For any other value, the robot picks the green block and sets output 106. After picking each block, the robot waits for 2 seconds and then places it down. To control the gripper, outputs 101 and 102 are used to open and close it. Now that our robot program is ready, let's connect the simulation to WinMOD using the connectivity add-on. First, activate the connectivity add-on in iiQWorks.Sim. To do this, go to the top menu and click on File, then Options, and open the add-on section. On the right side, enable the connectivity add-on using the slider. Once activated, you'll see a new tab called Connectivity. In this tab, we'll use the WinMOD Net interface to establish the connection. I've already prepared a WinMOD project. Let's start the simulation in WinMOD. Now switch back to iiQWorks.Sim. In the Connectivity tab, click on WinMOD Net, then choose Add Server. Next, click on Edit Connection. Since WinMOD is running locally on my computer, enter localhost as the address and use port 40001. This might vary depending on your setup. Test the connection by clicking on the corresponding button, and then, after the confirmation, click on Apply on the bottom right. Now we need to connect to the server by clicking on the little circle in the connectivity configuration and waiting until a green light appears. On the left side of the connectivity configuration panel, you'll see 2 sections, Simulation to Server and Server to Simulation. The Server to Simulation section handles the data flow from WinMOD to your robot simulation. This is where you'll configure the robot's input signals. Right-click on Server to Simulation and choose Add Variables. Then click on Reload Server Structure to load the available variables from your WinMOD project. Since we only need the robot's inputs and outputs, select the Signal Map section. Open it and navigate to the inputs of the robot. Start by selecting Input 119, which is the trigger signal for the rising edge. Then select Inputs 120 to 135, which represent the 16-bit integer signal for colorNum. Now go to the WinMOD variables we've declared. These should be Inputs 119 to Inputs 135. Select all of them together and click on Pair Selected to link them with the corresponding simulation signals. At the bottom of the window, you'll see the paired variables list showing the connections. If everything looks correct, you can close the Create Variable Pairs window. This completes the input mapping from WinMOD to your robot simulation in iiQWorks.Sim. Now let's configure the output signals from the robot simulation to be sent to WinMOD. Go to the Connectivity Configuration panel and open the folder called Simulation to Server. This section handles the data flow from the simulation to your external software, in this case, from KUKA Sim to WinMOD. Right-click on Simulation to Server and choose Add Variables. Next, navigate to the Output section of your robot. You'll need to select outputs 101 and 102, which control the gripper, and outputs 103 to 106, which are set depending on which case statement is executed in the robot program. Once you've selected these outputs, go to the WinMOD variables you've declared. These should match the output names, out101 to out106. Select all the corresponding variables on both sides and click Pair Selected. At the bottom of the window, you'll see the paired variables list showing the linked signals. If everything looks correct, you can close the Create Variable Pairs window. This completes the output mapping from your robot simulation to WinMOD. Now that all variables are paired, let's test the signal flow between iiQWorks.Sim and WinMOD. Click on Connected Variables to review all linked signals. This gives you a clear overview of which inputs and outputs are connected between the simulation and WinMOD. To monitor both systems side by side, resize your windows so that iiQWorks.Sim is on the left and WinMOD is on the right. Start the simulation in iiQWorks.Sim by clicking on Play. Let's begin with a test. Set the value of the colorNum signal to 5. This should trigger the default case. When input 119 receives a rising edge, the robot should move to the green block, grip it briefly, and place it down. Output 106 will be activated. Now change the value of color num to 10. When input 119 is triggered again, the robot should go to the blue block and activate output 103. Next, set color num to 20 and trigger input 119. The robot will move to the yellow block and activate output 104. Then, set color num to 30 and trigger input 119. The robot will go to the red block and activate output 105. Finally, test an undefined value like 50. Since this doesn't match any defined case, the robot will default to the green block again and activate output 106. This confirms that our switch case logic and signal mapping between iiQWorks.Sim and WinMOD are working correctly. In this tutorial, you learn how to simulate and control a KUKA KR10 R1100-2 robot in iiQWorks.Sim using a switch case logic based on input signals and connect it to WinMOD via the connectivity add-on. You configured impaired input and output variables between the simulation and WinMOD, then validated the signal flow by triggering different color num values to test robot behavior in iiQWorks.Sim.
We appreciate you watching. Don't forget to hit the subscribe button on the KUKA channel for updates and new videos. For hands-on trainings and courses, head over to the KUKA College. Keep exploring and learning with us.
Making automation easier.